Assalamu alaikum guys, and thank you so much for coming back to watch another one of my videos. So I just want to go ahead and say thank you to everyone out there who supported me up until now. Honestly, this channel only exists because of you guys. So, give yourself a pat on the back, and I'm going to give you a lot of cyber COVID-free hug right now. So what we're doing in this video. So in this video, we'll be working on a complete walkthrough of the statistics paper. So I'm talking about the S1. And this was just released on the 13th of January 2021. Okay, and this is aimed for the international A-level guys. So sorry GCSE guys and normal A-level guys, this is not exactly for you, but I still recommend you watch this video because it will help you with your papers too. Now I'm conducting the walkthrough as always, and in this paper thankfully there's only 6 questions, and it's been like that for the last couple S1 papers I say, and it looks like this is going to be the norm. But yeah guys, that's what I'm going to say, and without further ado, let's jump straight in now. So see you lot in a minute. Okay, number 1. So the Venn diagram shows the events A, B, and C and their associated probabilities. Now they want us to find in part A the probability of getting not B. Now when you got this apostrophe, it just means everything outside the B circle. Now we have 3 values. We have 0.15, so you can write over here. We also have 0.13 and 0.12. So we just have to add all these values up. And when you do that, guys, you should get 0.4. So that's nice and easy. Now next one, find the probability of A uniting with C. So this just means add up all the values in the A circle and all the values in the C circle. So we're going to add up 0.15, 0.20, 23, and 12. And when you add this up, you should get 0.35, 0.35, so 0.7. Okay, nice. And the last one, find the probability of A given not B. Now a nice way to write this is to expand it, yeah? So A given not B essentially means find the intersection of A and not B. So you can write here, intersection of A and not B over the area of B, of not B. So that's what you want, the area of not B. Now finding both of this is not too bad. We've already calculated the bottom part because we did it in part A. So we know on the bottom part is out of 0.4. Now the top half, the intersection A and not B. So all we care about is when do A and not B overlap. Well, we know where A is. A is all these, everything in the circle. So it consists of these 2 values, 15 and 20. Now not B, we said, is everything outside the B circle. So we have 0.15, 0.13 and 0.12. Now we can see that both of these circles, both of these events overlap at this single value, 0.15. That's the 2 values, that's the only value that these 2 have in common. So that means it'll be 0.15. And yeah, now we just put this in a calculator, and when you put it in the calculator, you should get an answer of roughly 0.375. And that's it guys, that's question 1 done. Alright guys, number 2. So the stem and leaf diagram below shows the ages and years of the residents in a care home. Okay. Now, just understand what this data is telling us. We have the ages over here. Now, these bars tell you, for example, the age of one person, which is 43. The second one would be 54, and for the third row, we have 9 people, and they're aged between 62, 63, all the way up to 69. And this goes all the way up until 97. That's quite a lot of ranges. Now for part A, they want us to find the median age of the resident. Now median, guys, literally just tells us to find the middle person, okay? Now to calculate the middle person, we could just count over here, or we could use the brackets over here to help us. This tells us again how many there are in each row. So if we add up all of these frequency values, this will total up to 31. Now the formula to find the median, guys, is straightforward. It's just half of this plus 1. So I'll write the formula. So median would be half of the number of people you have plus 1. And this is going to give us 16th person, yeah? So that's what we want, 16th person. Now to find the 16th person, best way to do it is just to count, because it's not really a big data set. So to count, we just start at the beginning. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the 16th person is here. So we write the median age is therefore 74. Easy. Now for B, find the interquartile range of the ages of the residents. Well, interquartile range is just simply the difference between the upper quartile and the lower quartile. Now to work out the upper quartile, we just have to find the third quarter of this group, of the person here. Well, just like in the first case, we said it's 31, so we add 1. So we need to find 3/4 of 32. Well, that's going to give us 24. So we're looking at the 24th person. Likewise, the low quarter is just the first quarter of 32. And that is the 8th person. So let's go ahead and find both. Well, to find the 8th person, count from the top here. So you got 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 68. So the low quartile is 68. And as for the upper quartile, I'm just going to count onwards from the median. So we've got the 16th person here. Therefore, we're going to have the 17, 18, 19, 20, 21, 22, 23, 24th. So 24th person is age 80. So our upper quartile is 80. Therefore, the difference between 80 and 68 is 12. So that's the answer, 12. Now, next one. An outlier is defined as a value that is either more than 1.5 times the interquartile range below the low quartile, or more than 1.5 times the interquartile range above the low quartile. So that's the outlier we defined. Now, determine any outliers in this data. Show clearly the calculations used. Okay, cool. First thing we're going to do is work out what 1.5 times IQ are below the low quartile and more than 1.5 above the upper quartile. So essentially, the first equation is this. It would be 1.5 times 12. That's going to give us, well, just calculate fast. 1.5 times 12, that's 18. And that's below the low quartile. Now, low quartile we calculated earlier was 68. So 18 take away 68, that's going to give us 50. So an outlier is anything below 50. Likewise, for the bottom one, it will be 1.5 times IQR, which is 18, above the upper quartile. So 18 units above the upper quartile, which is 80. So 80 plus 18, that's 98. So another outlier is anything above 98. Now we just got to look at the data set, guys, and see what values is below 50 or above 98. Now looking over here, there's nothing above 98 because the biggest is 97. But there is one below the, which is 43. This is the only outlier below 50 because the next lowest is 54. That means the only possible outlier is 43. Yeah, that's it. Now finally on part D, on the grid on page 5, draw a box plot to summarize data. Alright, not bad. Now box plot, let's go ahead and find it. So it's over here. So all you got to do for box plot is work out, well, 5 things. You need to put the minimum value and the maximum value. You also need to put the low quartile and the upper quartile. And lastly, you need to put the median. Thankfully, we have all these data set, yeah? So now just updating certain values here. We know that the low quartile was 68. We know that the median is 74 and the upper quartile was 80. Now, for the minimum, we have to be very careful because we just identified that there's an outlier. Now, the minimum value is never an outlier. It's the values after the outliers. So let's have a look. Since the outlier is 43, therefore the new minimum is going to be 54. And as for the maximum, we have 97. So 54 and 97. Let's put it over here. 54 and 97. So since we got the values, let's go ahead and draw a box plot now. Now the first thing you want to put is an outlier. We're going to mark an outlier with a little cross. So 43 should be over here. That's 43, yeah? And 54 would be over here. So just draw a line down. Okay. And next one would be the maximum, which is 97, which is at the end. So it should be over here. And then we're going to draw other values. So low quartile 68, which is around here. 74 median is here. And the upper quartile, which is 80, is nicely on that line. Now for the low quartile, median, upper quartile, we're going to put them in a box. So it has to be closed in. And for the other values between the minimum and the low quartile, we're going to draw a line connecting it. And over here, a line connecting this part. And that's it, guys. That's your box plot done. So let's move on to number 3. Alright, so this is the part where we need to use a calculator, because with a calculator you can get a lot of these questions done. So let's check it out. Now, the weights of packages that arrive at a factory are normally distributed with a mean of 18 and a standard deviation of 5.4. So let's just note this down, yeah? So we're going to have mu, which is 18, and sigma, which is 5.4. Okay, so that's our mean and standard deviation symbols. Now A, find the probability that a randomly selected package weighs less than 10. So this, in probability terms, this is the probability that the weight, let's call it the weight of packages, W, is less than 10. Now, how we're going to use a calculator for this one. So this is the part we're going to show you. So first things first, when you open up your Casio calculator, we want to go ahead and press the menu setup button. And we're going to scroll right down to number 7, where it says distribution. So press enter on distribution. And now when we look at this probability symbol, probability of W less than 10, this is known as a cumulative distribution, because this is trying to tell us the weight of all values up to 10. So this is accumulating. So we're going to press number 2, normal CD. Now this is part where it gets really important. We need to identify what the lower and the upper bounds are. Well, look at this symbol, we can see that the upper bound is 10. So we can go down and write 10. That's fine. However, the lower is quite tricky. Sometimes you think it's 0 because you're dealing with weights. But in fact, when you do a normal distribution, it's not necessarily 0. It could be less than that because of the way the function works. So to be very safe, we're going to just think of it as minus infinity, as if it goes on forever. And the best way to write minus infinity, guys, is to write minus 99999 and then press enter. Now go down to your sigma and mu values. We know sigma is 5.4, enter, and we know the mean is 18, enter. And then when you've done all of this, press your equal, and you should get the probability value that you want. So the probability that W is less than 10 is going to be approximately, and we're going to round this up to 3 significant figures, so it'll be 0.0692. 0.0692. That's it. So maybe I should put this in a little bit actually. Yeah, much better. Okay, cool. So that's question A done. Now, next part. It says that the heaviest 15% of the packages are moved around the factory by Jemima using a forklift truck. Okay, so before we carry on this question, it's better we look at this as a diagram. So let's draw a bell curve. Now, bell curves look like this. You always start with a little horizontal line and then you draw a nice little smooth curve like that. It's a symmetrical bell curve. And in the center, we write a mean of 18, because that's what it is. Now, it tells us here that the heaviest 15%, so the heaviest will be on the right side, yeah? So you can think of this as the weight, W. The heaviest 15% will be the last end of the tail. This area is going to be worth 15%, okay? That's what it's trying to tell us here. Now, they want us to find the weight in kilograms of the lightest of these packages, the lightest possible of that 15%. Well, the lightest will have to be at the start of it. This will be the lightest item, whatever package that is. Now, when we look at this as an equation, as a probability equation, this is telling us that the probability that the weight is bigger than L is 15%. That's what we have here. Weight that is bigger than L equals 15%. Now, when we put this in a calculator, we can't actually solve this because calculators only work with, if we remember, the CD, the cumulative distribution, and the PD. So we need to rewrite this in terms of the cumulative distribution form. So one way we can look at this, we know that this tail is 15%, but if we look at the y area, the left side of it, we can kind of figure out that the rest of the area is going to be 85% because all areas in probabilities have to add up to 100%. So the left side below L is 100%. So we can say that the probability that the weight is less than L is 85%. Now, let's use our calculator to work out what L is, yeah? So to work out L, press on, go to menu, press on again, go to menu, and this time go back to 7. Now we're going to go to number 3, which is the inverse normal. So this is kind of telling us to work backwards to work out what the original L is. So we press 3, and now for the area point, we're going to write down how big the area is. Well, the area is 85%, so 0.85. The mean and standard deviation are already given, so you just press enter. And that's it, guys. This is literally the L value they want, which is 23.5967. That's what the value L is. So we can say, therefore, L equals approximately 23 point, what should we say? Should we round up? Let's round to 1 decimal place, 23.6. Yeah. Now, to use a calculator for this one, we have to kind of literally say, in brackets, calculator work, calculator. We should do that for every single question, in fact, yeah, because they want to know how you did it. Okay. You could write on the steps you did in the calculator. That might be more, probably more efficient. At least that way they can see what you've done exactly. So you could say you did this in a calculator, and you can write the inputs you did. But yeah, that's pretty much how we do A and B. Now for the next part, it says one of the packages not moved by Jemima is selected at random. Now not moved is actually the ones where it wasn't moved. If we look at the previous paragraphs, it said that the heaviest 15% were moved by Jemima. So we're talking about the red area. That's Jemima moved it. Therefore, the white area is the part that was not moved by Jemima. So we're talking about the 85%. Okay. Now find the probability that it weighs more than 18. So this is simply a given that question. We're trying to find the probability that the package weighs more than 18, given that it was not moved by Jemima. So essentially, we can write like this: probability that the package weighs more than 18, given that given that it was not moved by Jemima. So we know that it was not moved by Jemima, meaning it's going to be probability that W is less than the limit, than the lightest weight. That W is less than the limit L, the lightest weight. Now we know what L is. L was 23.6, but we're going to leave that for a second. Now to work out this conditional probability, we've got to use the given that rules. Now the given that rule tells us this: when you got these two lined up like this, we have to firstly find its intersection. So we can say that the area where these two are intersecting, according to the bell curve, would be, well, let's have a look. Anything bigger than 18 covers this right hand side after 18. Everything bigger than less than L covers this side. So the only overlapping positions is here. So these are your intersecting point. So we know that these two intersect between 18 and L. So we can say on the top half, it will be the probability that W is between 18 and L. So you can write 18 less than W less than L. So that's where it's intersecting. And it's going to be over the second part. Probability W is less than L. Okay, so that's how we write it, yeah? So you always intersect them first, find out what they have in common. That's your overlapping area over the second half. Now, thankfully, we have all these values, yeah? And we don't even need to use a calculator, actually. Probability W less than L, we calculate, or we just identify that it's 85%. So it's over 0.85. And the top half, W between 18 and L, well, you don't need a calculator, because you know after L is 15%. And because this is a normal distribution and it's symmetrical, we know that the right hand side after 18 is 50% and the left side is 50% as well. Meaning this difference has to be 35%, because 35 plus 15 gives us the whole 50%. So that means the top half is 0.35. That's it. Now we just put that in the calculator, guys. So let me just fix this up quickly. So 1. So yeah, if you want to get out of this, always go back to number 1. Calculate. So it's going to be 0.35 divided by 0.85, and that's going to give us 7/17. As a decimal, that's approximately 0.412 to 3 significant figures. Cool. Now finally, guys, the last part. So delivery of 4 packages is made to the factory. The weights of the packages are independent, meaning they can be put in any order. So the guy could have put them in any random order, literally any order. Now find the probability that exactly 2 of them would be moved by Jemima. Okay, so we need to firstly identify what probabilities are. So when they say moved by Jemima, this is still talking about the heaviest 15%. So let's give this a name, yeah? Say let J mean moved by Jemima, yeah? Moved by Jemima. And what this tells us that the probability for this case is 15%. So the probability it was not moved by Jemima, let's call it N, would be 85%. So that's not moved by Jemima. Now let's think of all the possible ways you can arrange 4 packages to get exactly 2 of them to be moved by Jemima. So I'll give you one of them. Like for example, the first 2 packages could be moved by Jemima, so it could be J then J, and then it could not be moved by Jemima. So this is one combination. Another combination could be J, Jemima moved it first time, then she didn't, then she did, then she didn't. So you just have to literally write as many possibilities, and then that's how you get the answer. So another combination could be J, N, N, J. Another combination could be N, J, J, N, N, J, N, J, and lastly N, N, J, J. So in total, we see there are 6 ways she could have done it. So we know straight away that the question answer is going to be, well, the probability is going to be 6 different ways times. Now the probability that she moves exactly 2 of them, there's always 2 and there's always not 2. Probability again, one of them is 0.15. So it'll be 0.15 times 0.15 times 0.85 times 0.85. So just write nicely 0.15 squared times 0.85 squared. And then you should get your answer there. So I'm going to just do it quickly here. So 6 times 0.15 squared times 0.85 squared. And that should give us that result there, which is roughly to 3 significant figures, 0.0, what's that, 975. And that's it, guys. That's literally all you have to do. All right, number 4, guys. So here we go. Now, a spinner can land on the numbers 10, 12, 14, and 16 only, and the probability of the spinner landing on each number is the same. Okay, so it looks like the spinner has 4 different values. Now, the random variable x represents the number that the spinner lands on when it's spun once. Okay. Keynote here, yeah? It says that the probability of the spinner landing on each number is the same, meaning because there's 4 chances, they will have a quarter chance to land. Okay, cool. Now, state the name of this probability distribution. Well, if it's literally going to be the same every time, we call this a discrete uniform distribution. So we can say discrete uniform. Now, the reason why we say uniform is because it's all the same. We say discrete because they use single value numbers. There's no range of values, just single points. So this is a discrete uniform distribution. Okay, and if it helps, it's good to actually specify this, so to draw a table over it. Well, we can call this top part x, and we call this one the probability of getting that x value. We know that each x value could be between 10, 12, 14, and 16, and each probability is a quarter. So this is what makes it a discrete uniform. Discrete because the values are fixed, uniform because it's the same throughout. Yeah, cool. Now, BI, write down the value of the expected value of x. This is just the mean, yeah? Expected value x just means that you just times x with its probability and sum them up. Now, because it's all out of a quarter, a nice way you can write this is by factorizing a quarter. So it'd be a quarter times all of these values. So quarter plus 10 plus 12 plus 14 plus 16. Well, if you do this in a calculator, I've done it before, I actually got the answer to be 13. So that's our expected value. Now for the next one, find the variance of x. Now to find the variance of x, we need to firstly find something known as the expected value of x squared. This is the same thing as kind of the first one. The only difference is that you now square these values and multiply them against the probability. So it'd be a quarter times 10 squared plus 12 squared plus 14 squared plus 16 squared. Now in your calculator, I'm going to just quickly do it now. So it'd be 1 over 4. So it'd be 10 squared plus 12 squared plus 14 squared and then plus 16 squared. Doing this, you're going to get 174. Nice. Now therefore, the variance is literally the difference between EX squared, so 174, minus your expected value x squared, so your mean squared, so minus 13 squared. So in the calculator, it will be that answer take away 13 squared, which is 5. So that's it, that's your variance. Your variance is 5. Cool. Not bad for the first 2 parts. Now for the second part, it says a second spinner can land on the numbers 1, 2, 3, 4, and 5 only. Okay, so they're quite specific. Now the random variable y represents the number that the spinner lands on when it is spun once. And for C is exactly the same as B. So we're going to find the expected value y, and to do that, we'll just do the y values times its probability and then sum them up. So for the first one, it's going to be, for example, 1 times 4 over 30 plus 2 times 9 over 30, dot, 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 all the way up to 5 times 6 over 30. Okay? And then putting this in a calculator, I've already done it before, you should get an answer of 3. Okay, so quite straightforward. Next one, find the variance of y. So do the same method first. Before we get the variance of y, we need to firstly work out the expected value of y squared. Now, just like the previous question, you times the probability with the squared values of y. So 1 squared would be 1 times 4 over 30. So I'll put 1 squared plus 2 squared times 9 out over 30 plus dot 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 all the way up to the last one, which is 5 squared times 6 over 30. Okay, be very careful, guys. You never square the probabilities. You only square the value, the y, because it literally says y squared. So you square the y's. And then when you calculate all this in your calculator, this results to be in 10.8. And then lastly, to get the variance of y, I'm going to do it down here. The variance of y is just literally the expected value y squared, which is 10.8. Take away the mean squared, take away 3 squared. And that should give us 1.8. Cool. So that's not too bad. That's not too bad. Now, here comes the main part. So it says that the random variable w equals ax plus b, where a and b are constants and a is positive. Okay, that sounds a bit weird. So given that the expected value w equals the expected value of y, and the variance of w equals the variance of y, find the value of a and the value of b. Okay, cool. Now, when they give you this kind of statements, all you got to do is literally just do what they say and see what happens next. That's the best way of understanding it. So before we get to the second part of the equal signs, let's work out what the expected value w is based on that equation, yeah? So let's do the answer to D down here. We can say the expected value w using the expectation rules would be the expected value of everything inside here. Well, we can write that down. So we can say the expected value of ax plus b. Well, because a and b are constant, you just stick the expected value on the x. So it'd be a times the expected value of x plus b. Okay, and that's supposed to equal the expected value of y according to the question. Well, we know what the expected value of x is and the expected value of y is because we actually just solved it. Expected value x is 13 and ey is 3, so it'd be 13 and 3. So updating this equation here, we now have 13a plus b equals 3. So it looks to me that we're doing this simultaneously. Now for the second part, variance of w, yeah? So we can say that the variance of w equals, now the variance is kind of different. It's kind of different here. When you find the variance of that expression, so the variance of ax plus b, when you have a constant stuck to the random variable, you square it. But if the constant isn't stuck, then it becomes 0, because the variance just means the spread around a value. The spread around a fixed value is nothing. There is no spread because it's fixed. That's why the variance of b is nothing. So this equation is basically the same as a squared times the variance of x plus 0. We're not going to write plus 0. And that's going to equal the variance of y, because that's what equals according to the statement. Now we know what these two are as well, variance x and variance of y. Variance of y is 1.8 and variance of x is 5. So this is basically 5a squared equals 1.8. Now we just solve for a. So a is going to be 1.8 over 5 square rooted. So in the calculator you can write like this, 1.8 over 5. That means a is going to be 3/5. Cool. And I'm just going to put b on this side, yeah? If a is 3/5, you can solve for b. So b would just be 3 take away 13a. So we can write equals 3 take away 13 times your previous answer. Therefore b is going to be minus 4.8. That's it. Straightforward. So we've got a and b. Now last part, each of the two spinors is spun once. Find the probability that w equals y. Ooh, that's interesting. W equals y. Okay, to understand what this is trying to tell us here, we should firstly just realize that we only have two distribution tables, one for y and one for x. We do not have one for w. We can make one actually, but we don't have to. So let's go ahead and just stick with w equation. Let's update this w equation right now with our known values, yeah? So we can say straight here that w equals, what's that a value? 3/5. You know what? 3/5 is 0.6, yeah? So it'd be 0.6x and b is minus 4.8. Now all you have to do is find out the times when w equals y, or when this equation equals y. So when that means equals y, it means the chances when w equals 1, 2, 3, 4, or 5. Let's have a look. Let's test our x values. We have 4 different x values, 10, 12, 14, 16. When we plug in, let's say, x equals 10, w is actually, well, let's just do it on a calculator. It will be 0.6 times 10 minus 4.8. It's going to give us, what's that, 1.2? W equals 1.2. So when x equals 10, w equals 1.2. There is no 1.2 in this table, so that, if that was the case, that would equal 0. Probability would not be possible. Let's do it again for x equals 12. If x equals 12 here, so let me see if I can just go back here. Yeah, I can. the probability would be, again, it won't be a whole number, it will be W equals 2.4. So I've done this already for all of them, and it turns out that every value does not give you the answer. So the last one, 16, W is 4.8. So we can clearly see that the values are not the same as Y. You can never get the same value. So the chance of these two becoming the same is, well, never, because they're not the same. So the answer for E would be 0. So we can say for part E, the probability that W equals Y is 0, because the values for W do not match up the values of Y. That's it. That's literally all we can say. Yeah, and that's it, guys. That's number 4 done. So a company director wants to introduce a performance-related pay structure for her managers. Now, a random sample of 15 managers taken and the annual salary Y in £1,000, so Y in thousands, was recorded for each manager. Now, the director then calculated a performance score X for each of these managers, so they get some sort of rating, okay? Now, the results are shown on the scatter diagram in figure 1 on the next page. Describe the correlation between the performance score and annual salary. Let's have a look at this so-called figure 1, yeah? Let's see what's happening. Okay, so it looks to me like it's going upwards, yeah? Like, you know, as the performance score rates goes up, you seem to get more money, more salary. So it seems like someone with a top performance score gets a really nice salary, but people on the lower end don't get much money. We're still decent. So this to me seems to be like a positive correlation. So that's your answer. So the answer would be positive correlation. Okay, if you want to describe it carefully, you can say as the performance score increases, so does the salary. Okay, so something simple like that. It's only 1 mark. Now, next part would be this. Let's have a look. So the results are also summarized in the following statistics. So they give us the summed up values, the sum of X, sum of Y, and so on. SXX and the rest. Show that SXY equals 2006. Okay, so all you have to do is literally expand the formula. So SXY is defined like this. It's always the sum of XY. So always try and copy, oops, you don't use the E, it's like that. So it'll be the sum of XY. So sum of XY minus the sum of X, oh, not again. The sum of X times the sum of Y over the sample size. Well, what's the sample size here? 15 managers, so it'll be over 15. Now all you go do, guys, just plug in the values, yeah? So in the calculator, we're going to have literally 19,428 takeaway on the top line, 465 times 562 over 15, 2006. That's it. So just enter it just like that, yeah? And then you should get the answer. Expand this and replace this with values, guys. Now for SYY, it's the same thing. So it'll be the sum of, you don't have to write YY. We always write Y squared. The sum of Y squared, take away. I keep having trouble writing that sum sign. Minus the sum of Y times the sum of Y. So you could do sum of Y squared over 15. In your calculator, it will look like this. The sum of Y squared is 23,140. Take away and put the fraction button. It will be 562 squared. So be careful you don't use the same value, because 562 squared is not 23,000. That's one thing to note. Over 15. This gives us a decimal value of, just checking all the values entered correctly, 23,140. Yep, so you get 2083.7. Okay, they're quite picky in the statistics exams. They always round to 3 significant figures, so you can say 2080, yeah, just in case. 3 significant figures. Now C. Find the product moment correlation coefficient between performance score and annual salary. So product moment correlation, that just means find the R value, yeah? Find the correlation. So to find the correlation, it's always SXY over the square root of your two other S values. So SXX times SYY. Now, when we input things in the calculator, always use your exact answers, yeah? So don't use your rounded values. So let's go ahead and put everything in carefully, yeah? So in the calculator, we're going to have SXY, so fraction button, SXY, which is 2006, over the square root of, what's the square root of SXX? SXX was 2492 times, and now we're going to use our previous answer. So we're going to press the answer key, because that's already saved as the true answer. And then pressing equal, you should get roughly that 0.880. Okay, so I've actually just redone this question. So this is actually my second attempt on part C, because previously I actually got 0.881, and that's only because I used the rounded value of 2080 from the SYY, and that's not actually right. So guys, always use the non-rounded values, yeah? So from now on, from part D onwards, you'll actually see that I've been using R equals 0.881, but it won't be a big deal, you know, it won't be a big deal since you don't really have to use it again, except for part D. So yeah, let's move on to part D now. The director believes that there is a linear relationship. This is true because linear means a straight line, and positive correlations are straight lines, or lines of best fits, between performance score and annual salary. State, given a reason, whether or not these data are consistent with the director's belief. They are consistent, so we say yes, consistent, since R value is close to 1. Simple as that. E. Calculate the equation of the regression line of y on x in the form of y equals a plus bx. Give you a value of a and the value b, 3 significant figures. Okay, the calculated value b is just one simple formula, yeah? So you always do b first. You always do the gradient first before the intercept. So for b, it's just sxy over sxx. Always that, yeah? We have both these values. Sxy was 2006. So 2006 over SXX 2492. That's your value here. So it'll be approximately 0.805, and the value A is just basically y bar minus the value B just obtained times x bar. Y bar is just the average of y. So you look at the sum of y divided by 15. I'll show you in the calculator. So y bar is calculated this. You choose the sum of y, which is 562, over the sample size, which is 15. So that take away our value for b, we can just write answer, times, and again do the same thing, yeah? X bar would be the sample size of x, 465, oops, use a fraction bar, times, give me a second, yep, times 465 over the sample size 15, and that should be our answer for A. A is going to be roughly that, which is approximately 12.5. That's it. Now, for F, it says give an interpretation of the value of B. So B, if you remember, according to the equation, is the gradient. So what this tells us that for every time you increase X, B goes up by that factor. So just quickly reviewing what X was. It says X is the performance score. So every time you increase, let's say, the performance score by 1 point, the salary goes up by, in thousands, by 0.805 times 1,000, basically £805. So we can say for every additional point, so for every additional performance point, salary goes up by £805. Let's just times that value by 1,000 just to be sure. 0.805 times 1,000. That's how much it increases by £805. Now for the next part, we have to plot this regression line on the scatter diagram. Okay, so the regression line they're talking about is the y equals a plus bx. But before we do that, we need to update it. So now we have y equals 12.5 plus 0.805x. So I'm going to change the page right now, yeah? So let's have a look. So this is the graph we're looking at. So the graph we got is over here, and here is our equation of interest. Now, to plot this directly inside, we just got to pick two coordinates here. It's just a simple linear graph, straight line graph. So what I did, firstly, I try to figure out the coordinates when x is 0. So find the first coordinate. When x is 0, we're just left with y equals 12.5. So our first equation would be over here. Okay, so it would be 0 and 12.5. Now, next one I'll do is when x is 50. So in the calculator, I already did it. Replace x 50, you get y value 52.75. So that's going to be somewhere up here. So you can see it over here. Now all we do, guys, is just draw a straight line connecting that, and it should look something like this. And yeah, that's our equation done. Now going back to the next part, which is G, so G is done actually. It says that the director hears that one of the managers in the sample seems to be underperforming. Okay, so someone that's getting a low performance score. On a scatter diagram, circle the point that best identifies the manager. So we gotta just think carefully for this one, yeah? So to think about it, the best way to think about it is the one who's furthest away from the line. And the one who's pretty much getting a lot of money for doing pretty much way less than somebody else. So the one I can see right now is this guy here. So I can see that this guy over here is clearly underperforming. How? Is because he's got a score of 25, yeah? But he's making a ton of money. Another guy that's getting the same amount of money is a guy who got a score of 42. Like he's pretty much working like literally nowhere near as hard as him, but getting the same money and getting way more money than these other guys. We don't know the reason why, but it could be an outlier, or this guy just pretty much used to be here, but pretty much just kind of chilled back. That's why he's getting a lower score. So our result would be this one, and the coordinate here is 25, 48, 25, 48. So we write here 25, 48. We don't have to write, but they said circle. We've done that. Next one. The director decides to use this regression line for the new performance-related pay structure. Estimate to 3 significant figures the new salary of a manager with a performance score 30. Cool. So just pretty much use this equation, replace x with 30. So we're going to have now, so just going here, I'm just going to go back here. So delete this, put 30 equals, you should get a salary of 36.65 times 1,000, so times it by 1,000. That's his salary. £36,650, which is to 3 significant figures, approximately 3,6,700. That's it. I think we're done here. Alright, number 6, guys. Let's do it. So a disk of radius 1 centimeter is rolled onto a horizontal grid of rectangles so that the disk is equally likely to land anywhere on the grid. Okay. So you got a disk of radius 1. So let's draw this as we go. Disk of radius 1 centimeter. Now each rectangle is 5 centimeters long and 3 centimeters wide. So just draw a rectangle here for a second. 5 centimeters long, 3 centimeters wide, so 5 by 3. There are no gaps between the rectangles and the grid is sufficiently large so that no disc roll off the grid. Okay. Now if the disc lands inside the rectangle, so you're going to roll this, see if it lands in there, without covering any part of the edges of the rectangle, then the prize is 1. So I think there's some sort of grid. So you've got multiple rectangles, you roll it and it has to land inside the rectangle. If it lands on top of the line or between 2 rectangles or 3 or 4 rectangles, you don't win. Now by considering the possible position of the center of the disc, show that the probability of winning the prize of any particular row is a fifth. Okay, easy way to do this, guys, yeah? This was quite challenging because I went through this several times to make sure I understood it. Now, from my understanding, the best way to do this is you just draw a rectangle, nice simple one, and then just place the disc anywhere for a second, yeah? The best way to place it is always in the top left corner or top right corner, somewhere in the corner so you can measure it properly. So I'm going to put this circular disc, let's say it's like that, yeah? Just for sake of convenience. We know the radius is 1 across here, so that means the diameter is 2. So let's just label it 2. And we know that the one length is 3 centimeters and the other length is 5. Now, best way to understand this is that when you roll the disc, we need to firstly ask ourselves, how much of the width and the length can it fit? Well, if you're looking at the width, let's say the width is 3 centimeters, it should always have some sort of gap of 1 centimeter long. So what this 1 centimeter is trying to tell us is that as long as there is a 1 centimeter gap between either end, which there always will be if it fits, then it will fit. So we can say that the probability that it fits in this width will be 1 out of 3, as long as that exists. Now for the length across, there's always going to be a gap of 3 centimeters. So just like the width, the probability that it will fit across this length would be how much is remaining, which is 3 out of the possibility of across the 5, so 3/5. That means therefore the probability that it fits in the area would be width times length. Probability of width times probability of length, which is a third times 3/5, which is 3/15, and that's the same as 1/5. Okay, so moving on to part B. So now we have a group of 15 students, each roll the disc onto the grid 20 times and record a number times x that each student wins a prize. So that's why I wrote n equals 15. We've got 15 students, so that's our sample size. Now the results are summarized as follows. They tell us that the sum of x is 61 and the sum of x squared is 295. Now find the standard deviation of the number prize won per student. Okay, so standard deviation, this is just like one of those like straight up formulas. So the formula for standard deviation is this. It's the sigma value of x, which equals, firstly, the sum of x squared over the sample size, which is 15. Take away your mean squared. So mean again is the sum of x over n. So it'll be sum of x over n, which is 15. But this time you're going to square the result. And lastly, when you calculate all of this, we need therefore square root our final answer. So we're going to do this all at once actually. So in the calculator, let's do this. We're going to put the square root sign, guys, and then put the fraction button. The sum of x squared is 295 over, and then n, which is 61. Oh, why did I write 50? Sorry, over 15. Take away, and the next fraction button. But this time, instead of that fraction button, we're going to put a little bracket here, just to make it easier. And then inside here, we're going to put, what is it, sum of x, which is 61 over 15. And all of this is going to be squared. Now, when you put this carefully in the calculator, and hopefully it's all right, press equals, and you should get this kind of mixed answer. Press SD, and this is your final result. So you can say that sigma x is approximately, to three significant figures, 1.77. That's it. So that's the standard deviation of x. Now, next bit. It says that a second group of 12 students each rolled the disk onto the grid 20 times. So now we've got a second group. So we can just imagine this is group X. This could be group Y, yeah? Okay, 20 times. And the mean number of prizes won per student is 3.5 and standard deviation 2. Let's just write it down, yeah? So Y bar here is 3.5. Sigma Y is 2. Cool. Okay. Find the mean and standard deviation of the number of prizes won per student for the whole group of 27 students. Oof. Okay, so we're talking about X and Y, combining them, yeah? Okay, so for this particular case, I'm going to call this whole group Z, yeah? So that's the whole group. The whole group is Z. We know straight away the N here would be 27, but we still need to calculate a lot of the other statistics. Now, what can we do? So what we need to do is pretty much find the summations of Y and Y squared. So let's do that. So that's our target. Once we work out this and that, then we can sum them up with the previous ones. We can add them both up, the sum of x, sum of y's, to get sum of z. We can add up the other sum of squares to get sum of z squared. So let's do it. To get sum of y, we can firstly work with the mean, right? Because they give us a mean. Let's just write the general formulas of everything. So over here we can say y bar equals the sum of y over n. N in this case is 12. We know what y bar is. Y bar is given to be 3.5. So all we do is therefore times this 12 across. This will give us a y bar result of 42. So that's one thing done. So now we got y bar is 42. So that's good. Let's just update this result here. Our final result will be over here on this page. Now for the sum of y squared, we need to somehow incorporate standard deviation. So we're going to kind of copy out this formula here, yeah? So let's do it over here on the next page. We can say that sigma y equals the sum of y squared over 12. Take away the mean. We know what the mean is actually of y. The mean of y is given to be 3.5, so it'll be 3.5 squared. Take away 3.5 squared, all of that square root. And this is supposed to equal the sigma y value of 2. Now, this is just a case of rearranging the formula, guys, yeah? So you can just say, okay, therefore, if we square both sides, we're going to have sigma y squared over 12, take away 3.5 squared equals 2 squared, which is 4. Now, just doing a quick maths here, 4 plus 3.5 squared, so I'll just do it here. 4 plus 3.5 squared, that's going to give us 65 over 4, 16.25. And then times the answer by 12, that will give us 195. So that's our result. The sum of y squared equals 195. Cool. So that's almost done. Now we've got these two components. We can just combine it with to get the sum of the whole group, yeah? So sum of z. So let's do it here. We can say that therefore the sum of z equals the sum of x plus the sum of y. Let's just note this in a calculator. The sum of x is 61 plus the sum of y is 42. That gives us 103. Perfect. And the sum of z squared, well, the first one was 195. We're going to add that to the sum of x squared, which was 295. That gives us 490. Perfect. Now we got the main statistics, so we can pretty much work out the mean and standard deviation easy, yeah? So we can say, therefore, the mean z bar equals the sum of z over the sample size, which is now 27. So dividing both, 103 divided by 27, you get exactly, roughly, 3.81. And for the next value, sum of z squared, so we need to find sigma z, standard deviation z. This will be the sum of z squared. So I'm going to put this as a whole value here. Actually, I'll do it as a formula. Sum of z squared over 27. Take away the mean squared. So z bar squared, all of that square rooted. We're going to save the previous mean as the answer in the calculator, just to simplify the working out. So what we're going to have now, we're going to use a square root button, fraction. So sum of z squared was 490 over 27. Take away our answer squared equals this. That's our final sigma value, 1.8. Actually, no. It'll be 1.90 if you round it up. 1.90 to 3 significant figures. Yeah, and finally, guys, part D. So 27 students also recorded the number of times that the disk covered a corner of the rectangle and estimated the probability to be 0.2216. What? Okay, corner of the rectangle. So I think what it's trying to say here is that if we just imagine a corner here, so let's imagine 4 rectangles now. Okay, so all the same length, we know they're basically 5 by 3, yeah, each one. And now the only time we can hit a corner if it overlaps 4 rectangles. So this would be like one example. This would be the best way to look at it. You got a circle, radius 1, touching the corner, which is like a vertex, overlapping 4 rectangles. So this is what I think they're imagining. But let's keep going. Explain how this probability could be used to find an estimate for the value pi. Okay, cool. This is the kind of question where I think almost nobody can get it right here. This is very tricky. I don't fully understand this question myself, but I'm going to give it a go so I can help you guys. So let's just take this theory right now. Now let's try and find the probability that this area of the circle is covering 4 rectangles instead of 1. Now the only way this can be possible is, like we said, it touches the corner. Okay, and now what is the length and the new length and the new width of this whole shape? Well, if it's 5 across, that means it must be 10 all the way. And again, it must be 6 all the way up. So the probability that the area of a circle, which by the way guys, area of a circle is pi r squared, and we know that the radius is 1, so it'll be pi times 1 squared. So the area of the circle is actually pi, conveniently. We know that the probability is going to land in here in 4 different regions. It's going to be like this. The probability would be 4 different regions of pi out of 60, because the area is 6 times 10, so that's 60. And that's going to simplify to pi over 15. Now, therefore, because we know it's pi over 15, to find an estimate for this probability, so they said that the probability they got was 0.2216. That's the estimate. Yeah, we're choosing a true value of pi, by the way. They just want like a value roughly close to this answer. We can say now that since the probability is 0.2216, I'm guessing that's what they got. This is probably 0.2216. The equation will be this now. I'm going to go to the next page. It will be 0.2216 equals pi over 15. Therefore, a pi could be estimated to be, now just times these two answers, 0.2216 times 15. Well, that's your answer, 3.324. Yeah, so this is what I think, guys. Yeah, this is the only logical thing I can think of it. It covers 4 regions, and the area is pi, so it has to be 4 pi over the total area of the rectangle, which is 60. And that simplifies pi 15. If you guys got other ways of working this out, please let me know. If you don't understand how we did part A and D in this question, again, just give me a message and I'll try to help you. I think B and C is not too bad. B is quite standard. C is a bit tricky, but it's just another way of solving these questions. So I think out of the whole paper, number 6 was definitely probably the most unique one that we've ever seen. But yeah, other than that, guys, I hope you guys have a lovely day, and I'll see you in the next video.